Okay. Okay, so good evening, everyone. Today we'll be starting with MCQs on amino acids. This is the first series of the lecture. We'll start with multiple questions regarding amino acids, so that students can learn from various background, biological sciences, health sciences, uh, can learn so much about amino acids and biochemistry in general. So today will just be only questions. So the first question we are starting with, question number 1. All alpha amino acids contain which functional groups? Every amino acid have the functional group every amino acid has the functional group, the carboxyl functional group, and amino acid. That is, the carboxyl functional gives you the name acid. The amino group gives you the name amino. So combine together, say amino acid. So it has the carbon attached to the alpha carbon. So I have hydrogen and arrow group, while the N here has an hydrogen too. So this is amino, and this is what? Acid. So every alpha amino acid contains these two basic functional groups, the amino group and the carboxyl group. Question number 2. The general formula for an alpha amino acid is what? Which is what I just did in the previous one. This is the amino group. This is the carboxyl group. And this is the CH. Then R here determines the individual amino acid. If the R is H, we say it's glycine. If it is CH3, we say it's alanine. If the alanine has a phenyl group, we call it phenylalanine. If the phenyl group in the phenylalanine has hydroxy group, we call it thyroxine. So amino acids are amphoteric. When we say ampho, the ampho, or if you underline the word ampho, means amphi. Amphi means something that have a dual property. Like we see amphibians. Amphibians have organisms that can live on both land and water. So we say they are amphibians. So amphi or amphoteric means that compound or maybe molecules that have both acidic and basic properties. Like the amino acid has the acidic properties, which is on the carboxyl group, and the basic property, which is on the amino group. At isoelectric point, Pi. An amino acid is what? Is neutral. Is neutral. Isoelectric. When you say iso, it means that at equilibrium. Isoelectric, when the positive charge is equal to the negative charge. So the charge will just cancel out. So say they are what? They have no net charge. So it means there's a zero net charge. That's what I mean by isoelectric point. Isoelectric means neutral. The zeta ionic form contains dash, both positive and negative ions. The amino group will have NH3 plus, while the carboxyl group will have COO minus. That will say they are what? They are zeta ions. Which amino acid is optically inactive? The answer is glycine, because glycine have no chiral center. Has no chiral center. If I'm asked to draw glycine, I will have if I'm asked to draw glycine, I'll have C NH3 COO minus hydrogen. So this is glycine. So a chiral center means that a carbon there will have 4 bonds attached to it. Now this is the alpha carbon that makes us to call it alpha amino acid. So this one is one functional group. This is one other functional group. But these two functional groups, there are 2 hydrogen here. So because of there are 2 hydrogen, we say the molecule has no chiral center. If we had CH3 here, CH3, we will not say this is another functional group. So it will not be 4. So alanine is optically active, but glycine is optically inactive. Which amino acid is acidic? Which amino acid is acidic? When we say acidic, we don't mean the basic 2 functional group. For example, if we say COO minus and C NH3 hydrogen. So the arrow group here is what we are looking at. It is the arrow group that will determine if the amino acid is acidic or basic. If the amino group has, let's assume that we are removing the CH3. Let's assume that the R here is having a functional group that has a COO minus. We'll say the amino acid is acidic. An example in that scenario is what? Aspartate. Aspartate is acidic in nature. It has one additional CH2 and COO minus. So aspartate is acidic in nature. So which amino acid is basic? When I would say it's basic, it means that the arrow group have an amino group. The arrow group have an amino group. So example here, we have glutamate, histidine, serine, and valine. So the answer here is what? Histidine. Glutamate is an acidic amino acid. Serine is hydrophilic and neutral amino acid, while valine is hydrophobic and neutral. So which amino acid is non-polar? When we say non-polar, that means it cannot be dissolved in water. And the properties that makes them non-polar is because they must have what's it called? They must have a polar group attached to them. Close the door. Hello? So we have which amino acid is non-polar. Non-polar means they don't have any functional group like OH, SH, NH2, COO minus. So any amino acid that doesn't have these functional groups are non-polar amino acid. Serine has a functional group of OH. Cysteine has a functional group of SH. Asparagine has a functional group of both N and CO. While leucine doesn't have any polar functional group. So the answer here is what is leucine. Now, polar uncharged amino acid, polar but uncharged. So if it has COO minus on the arrow group, we'll say it is polar and charged. If we have NH3 plus on the arrow group, we say it is polar and charged. Or we say polar uncharged, which means it has a neutral functional group. Valine is non-polar. Phenylalanine is non-polar. Isoleucine is non-polar. The only one polar here is serine that has hydroxy group. So it is polar, but uncharged, doesn't have a charge. Now, essential amino acid must be what? We say they are essential because they must be taken from diet. Our body cannot produce them. So they're essential to us. If our body can produce them, we'll say they are non-essential amino acids. So they must be obtained from our diet. That's how I would say they are what? Essential amino acids. Which of this is essential? There are three essential. We have glycine. Our body can synthesize glycine. Our body can synthesize alanine, but our body cannot synthesize lysine. So lysine is an essential amino acid that must be present in our diet. Which is non-essential? We have methionine is essential. Threonine is essential. Alanine can be synthesized by the enzyme alanine aminotransferase. Tryptophan is also essential. Now, sulfur-containing amino acid. Sulfur-containing. So the answer here is what? Is methionine. The answer is methionine. Methionine and cysteine are the only sulfur-containing amino acid. So the answer here is what? Is methionine. The answer is methionine. Please, others should join and drop a comment. Aromatic amino acids. When we say aromatic amino acid, we mean amino acids that have a benzene ring or aromatic ring. Benzene ring or aromatic ring. So we'll say valine, cancel. Alanine, cancel. Aspartate, cancel. So the answer here is what? Thyroxine. Thyroxine contains an aromatic ring, NH3 plus hydrogen. So for thyroxine, we have CH2, then we have a benzene ring. So this is thyroxine. So this ring here makes it aromatic. And they absorb light at 280 nanometer. 280 nanometer. They absorb light at 280 nanometer. So we have question number 16. So amino acid is dash. So we say there's an amino acid that's called an amino acid. Why is it called amino acid? Because the amino acid, the amino group is a secondary amino group. Let me show you what I mean. Let me show you what I mean. Let me show you what I mean. So now for this amino group, every other amino acid that are found in proteins are they are primary amino acid because the amino group is free. But for proline, proline looks like this. Uh, so the proline looks like this. The the arrow group is attached to the amino group. So if you have C, C, and this COO, then the arrow group that's supposed to be here, the arrow group that's supposed to be here is attached to the amino group. So this amino group becomes a secondary amino group because it has two bonds attached to it. One going to the alpha carbon, the other one going to the arrow group. So we say it's an amino acid. So it's an amino acid. So we have an amino group. So the answer there is what? Is proline. Answer is proline. Now peptide bond is also called an amide bond. It's also called an amide bond. It's not an ester bond. Esters are made when two uh, uh, two molecules, one the carboxylic acid, the other one the alcohol. That's when esters are formed. By ether bond are bonds between an oxy bond between two carbon atom. Hydrogen bond is usually between hydrogen and oxygen. While is the weak bond, while ester bond is a covalent bond. So peptide bond formation involves condensation because water molecule is produced. It's called when two amino acids are condensed to form a dipeptide, three tripeptides, and so forth. We have so many, which is called a polypeptide. Uh, so we have is a condensation kind of reaction. So we have something like this. Let's see. So this is one amino acid. This is another amino acid. So the bond between this carbon and this nitrogen, this carboxylic carbon of one amino acid and an amino group of the second amino acid is called the peptide bond. And it's a condensation kind of reaction where water is produced as a byproduct. Then if you want to break them down, peptide bond formation is involved condensation, but peptide bond breaking is called hydrolysis. In case it's called hydrolysis. You want to break it out, you have to bring in water to break it out. If dipeptide contains two amino acids, okay, look at the question I said in the earlier this thing. Peptide bonds are broken by hydrolysis, which you have to bring water, like what I discussed, what I explained in the previous slide. So bonds between cysteines forms a disulfide bond. A disulfide bond. A disulfide bond is between two CH2 SH. This is cysteine. So we have another cysteine. CH2 SH. So when this sulfur reacts to this sulfur to form a bond, that bond is called a disulfide bond. These two hydrogen will be released. This hydrogen will be taken out, so it will be just SS. So that's a disulfide bond. Amino acid buffer solution because they are what? Amphoteric. This was what I was explaining earlier. They have the ability to accept or donate electrons, so they can behave like an acid and also behave like a base. So we have, you said you can't hear me? You said you can't hear me? Uh, Brother Joe, you need to change they are very visible from my own area. You need to change maybe the resolution of your own phone. Go to your YouTube settings and change this to higher resolution. So nihydrin gives the color with most amino acid, purple color. That's the test for most amino acid, purple color. Proline reacts to nihydrin. They say with most amino acid, but proline, because of the amino acid in proline is a secondary amino acid, it will give a yellow color. So nihydrin reacts with secondary amino acid to give a yellow color. Xanthoprotect test detect what? Aromatic amino acid is a test that is used to detect aromatic amino acid present in the solution or in the protein. Millions test is used to determine phenol group. When you say phenol group, not phenyl group, phenol group. So because we have phenylalanine and thyroxine, phenylalanine and thyroxine. So millions is used to test for amino acid that has a phenol group. An example is thyroxine. Thyroxine has a benzene group that has what? OH. So we call it a phenol. Sakaguchi test is used to test for amino acids. Example, amino acid that have guanidino group. Guanidino group, and the answer is what? Arginine. Now, when we talk about arginine, the guanidino group of arginine is that if you to draw the amino acid, we have hydrogen. There are about how many carbon of arginine? We have about 3 carbons. Then we have attached to a nitrogen. That nitrogen now has other attachment of a carbon with an amino group, a carbon with an amino group. So this circle here is called the guanidino group. So the Sakaguchi test is what can detect this part of amino acid. So we use it to determine if arginine is present in a protein. Lead acid test is to test for sulfur-containing amino acid. Example of sulfur-containing amino acid is methionine and cysteine. Okay, somebody asked what's the difference between primary and secondary amino acid. The primary and secondary amino acid, we have the primary amino acid is that the amino group is free. For example, this is what we have. Then is 3. This is hydrogen. A primary amino acid means that this amino acid is free. It's not attaching to any other thing, just hydrogen. But the secondary amino acid, we have similar stuff. Now we have C, C, C. So you can see that there's a carbon linking to hydrogen. So this NH becomes 2 or 1, as the case may be, or 1, as the case may be, becomes 1, as the case may be. So this amino group is now attaching to another carbon group. So because of the amino group have attachment to this carbon and attachment to another carbon, so this amino group becomes a secondary amino group. So that is why it is called an amino acid. Brother Joe, did you understand it now? Brother Joe, drop your comments if you've understood. I just explained. So electrophoresis separates amino acid based on dash. Electrophoresis separates amino acid based on dash, pH and charge. pH and charge for amino acid. If it is for proteins, it will be charge and mass or molecular weight. To be charge and mass. But for amino acid, this is pH and charge. Paper chromatography. So we have paper chromatography separate based on what partition coefficients. When we say partition coefficients, we talk about their solubility in the solvent. So usually it is based on putting a paper in a solvent and docking our sample. Now, the solvent will be migrating via capillary action. As they are migrating, they will be pushing the sample up. So the sample will be moving based on its affinity to the solvent. If the sample does not like the solvent, the sample will not move. But if the sample is soluble in the solvent, the sample will move. So it's called partition coefficient. Amino acids are the building blocks of what? Proteins. Take note of that. Are the building blocks of proteins. Biological function of amino acid includes formation of enzymes or protein. They are not involved in insulation. They are not involved in membrane bilayer. They are not involved in DNA storage. No, they are involved in enzyme formation because enzymes are protein. That's just the idea. When we say amino acids are the building blocks of protein, protein can also serve as enzymes. So tryptophan is a precursor of DASH. Tryptophan is an amino acid that is used to build some very essential biological amines. They're called biological amines. Example is serotonin. Tryptophan is used to synthesize serotonin. So if tryptophan is lacking in your diet, it will be difficult for you to synthesize Serotonin, which will also affect your mood. To also affect your mood. If are you happy? Are you sad? Serotonin is involved. It also involves in sleep-wake cycle. It also involves in alertness. So we have okay. So if you understand what I'm doing, please give me a thumbs up. And if you have not subscribed to the channel, please subscribe. So we have this answer. This question is thyroxine is a precursor of dash. Thyroxine, lactose, cholesterol, and dopamine. Now here we have two answers in this question. Thyroxine is used to synthesize thyroxine. It's also used to synthesize dopamine. It's also used to synthesize dopamine. So we have two answers there, A and D. So if you're given such question, know that the answer, you have two answers in one question, A and D. So if you have such in the question, they will make sure that the available, you can choose one more than one option. If you choose one option here, you failed it. You have to choose the two options, thyroxine and dopamine. Histidine act as a buffer. Histidine act as a buffer. Sorry, there was actually a network glitch. There was a network glitch. So histidine act as buffer due to the imidazole ring. The imidazole ring of histidine has a pH range around 6. It's close to 7. So then that is what confers buffering capacity of hemoglobin. It is the imidazole ring of histidine. So it has a buffering capacity close to physiological pH. So it will resist any change in the blood pH. So histidine is an amino acid that is present in hemoglobin protein that serves as a buffering amino acid to the blood. Most amino acids occurs in proteins as L form, while that of sugar or glucose is D forms. But for amino acid is L form, that natural configuration. The reactions of amino acid with nitrous acid will produce alcohol, but biological deamination of amino, this is just deamination of amino acid. If we use nitrous acid, we produce alcohol. But if it's occurring in the biological system, no longer nitrous acid will be used, but enzyme will be used. And those enzymes will form a ketone of the amino acid. They form an alpha keto acid of that amino acid. We talk about deamination in the biological system. A ketone will be formed, but deamination in presence of nitrous acid outside the biological system, alcohol will be formed. Decarboxylation produces anamines. So decarboxylation means, in fact, that's what happens in the synthesis of dopamine. Is deamination of the carboxylation of the carboxyl group. So if you have an amino acid like this, NH3, hydrogen, CO minus, CH3, or CH2, benzene OH. Then we have, and you decarboxylate this, you have an amine. This is only this one will be present, so it's called anamines. That's what we see in dopamine. I think even in serotonin, I think so. But the major one here is dopamine. The carbonization of L-dopa will give dopamine. So glycine participates in synthesis of dash. Heme, that is what we use. We use glycine to synthesize heme that is present in hemoglobin. Protein folding is driven by non-polar residues involved. When they say non-polar residues, they mean those amino acids like leucine, isoleucine, valine, alanine, phenylalanine, tryptophan. Because they are non-polar, they involve in hydrophobic interaction. They'll involve in hydrophobic interaction because they are non-polar. So the question already is telling you the answer. So protein folding is driven by non-polar residues. Involves in what? So non-polar residue, of course, they will not like water. They will form hydrophobic interaction. So that is why C is the answer. So we'll see next week Saturday for the second series. We'll see next week Saturday for the second series. Thank you very much and God bless you. Do you have any question? Do you have any question to ask? Uh, uh, Buffer means the ability or capacity of a solution to resist change in pH. So that's what buffer does. It will resist the change. As you're adding acidic basic solution, it will try as much as possible to still maintain the same pH. So the lecture will be on YouTube live. You can actually go back to the lecture and watch again. Also share with your colleagues that will be having an exam in March. I'll be having an exam in March. So share with them so that they can learn multiple choice questions with regards to general biochemistry. Next week, Saturday, we'll treat almost 40 questions again. So by the time we finish, you'll be having nothing less than you have a grasp of wherever the question might come out from. Thank you. See you next week, Saturday.